So here we've got our sand, our higher organic matter soil, and our standard just soil that we found out in the garden this morning. So a couple things I want to hit on is that I want to talk about noting the color. So you can see here the sand is kind of pale in color, especially in comparison to our high organic matter soil. And so this sand is composed mostly of mineral matter, so it's basically larger stones that have then, through some sort of erosion, have broken down into smaller and smaller particles. Whereas our higher organic matter and our compost here is made from dead plant and animal material. So as plant and animal material breaks down, it turns into what we refer to as organic matter. And this soil, you can see, has quite a bit of organic matter in it based on its rich black color. And a couple of other things that you can see is that it stays quite a bit fluffier. It has a lot of air pockets within it, and it's just retaining the moisture and water a lot quicker and a lot longer than even our standard garden soil here, which does have some organic matter mixed in with it, but not nearly the high content that our compost mixture does. And so here you can see that as we move it around, that it's still holding some moisture, so it is darker in some places. And then you can see it does have a little bit of clay mixed into the soil, because you can form these, as whenever it's wet, you can form some clumps that hold together like modeling clay would. And there's also a good amount of sand here, as well as silt particles, that make this a really well balanced soil that allows us to hold the right ratio of water and air within the soil profile or within the ground. So another thing with our different chemical compositions of our soil, sand is what we would consider an inert material, or a material that does not have a positive or negative charge. So it doesn't attract things like water or other soil chemicals or elements that would have a charge. So organic matter, on the other hand, has a negative charge. And so that means that the organic matter particles will attract oppositely charged elements. So anything that has a positive charge will be more likely to adhere to the outer surface of organic matter particles. So this can be really good whenever we're trying to increase what we call our water holding capacity, or retain more water within our soil. So organic matter is good for that. Our other negatively charged soil particle is clay. Clay has a negative charge. Most clays have a negative charge as well, and will hold positively charged ions or positively charged particles within the soil. So this includes some of our soil nutrients as well as water. In this experiment, we're seeing how liquids move differently through different types of soils. What you will need for this experiment is grape Kool-Aid or a different colored liquid, a coffee filter, a rubber band, and a clear plastic cup, as well as some soil samples. You can use as many different soil samples as you want. Today we're using 3 different soil samples. You mix your grape Kool-Aid drink according to instructions, but leave out the sugar. Then you will pour the mixture through your different types of soils. Make sure to take notes on how quickly the liquid moves through the soil, what color the soil is after the liquid has gone through, and what color the liquid is at the bottom of the cup. You may also want to try this with different colors of liquids to see if you get different results. Note the changes in the color of each of the liquids in comparison to our original grape mix. Do you see any color differences, and why do you think that may be?